to my academy. Today I'll be not teaching you exactly, but these are the shortcuts review that you need to know before you go to the exam. So please note down these notes. These are just the notes. I'll be conducting a separate teaching for this part. Just note down the formulas right now. The first in this chapter that you need to know is change in concentration. Okay, change in concentration. Okay, what am I talking about? Let's just understand what are these things. Change in concentration. It says supposedly if reactants form products, then Kp is the constant. It's equal to products concentration upon reactants concentration. This is very important, the concentration ratio. Okay, it says there are three categories here. Okay, you need to know each and every. If Q comes out to be less than Kp, okay, Q is equal to Kp and Q is greater than Kp. If these three happen, then this shows that reactants concentration is greater than products concentration. In this case you will see that reactants concentration is equal to products concentration. Here reactants is less than products. So what does this show? This shows if this is happening, reactants are more than P, then it should be forward reaction, forward direction of the motion of the reaction. Then here it is an equilibrium stage. It is at equilibrium stage, and this is going to be your backward reaction. Okay, remember there's one note here, okay, that you really need to understand is if reaction has solids mentioned. Okay, solids will be mentioned like this. Okay, they do not have any effect, do not have any effect, they do not have any effect at equilibrium. Okay, remember the change in concentration of the solid things do not affect the equilibrium will not be changed. Okay, this you should remember. If it is containing any of the solid products, it should not be included. Okay, solid things are not included. Okay, next, second point says, it's very simple. It says effect of pressure. Okay, if you are changing the pressure, then what's gonna happen to the reaction? Effect of change in pressure, that is PT, that is total pressure. You'll see it says that if you are increasing PT, if PT is increased, okay, then what will happen to the reaction? If PT is increased, then reaction moves where volume, I'm underlining this, volume is decreased, means the reaction will move to that side where volume of the contents of the reaction is decreased, that is towards less moles of gases only. Okay, towards the less moles of gases only. Suppose I'll make you understand this. Let's say we're not doing any understanding part here. It's just the review that you need to go through before you go to the exam. I'll be conducting a separate understanding on this. Okay, so stay tuned. If AA goes to as B, capital B, and this has a content X, okay, the quantity is X, then we say that quantity, okay, of product, quantity of the product X is the quantity of the product, is directly proportional to 1 upon P whole this raised to the power delta Ng by 2. Remember, this is very important. If you know this relation, you can crack any question. Okay, now what we are talking about here is you can see it more clearly. It says there are three cases. Okay, there can be three cases. First, delta ng greater than 0, delta ng equal to 0, delta ng less than 0. These are the three cases. Now what happens here is, if you've increased PT, if PT is increased, therefore volume will decrease. That means 1 upon P will definitely decrease. This is increasing, obviously. If this is increasing, then volume will decrease and corresponding pressure will decrease. So you need to have this relation. Now what it says, okay, if this is happening, means 1 upon P raised to the power delta ng. What will happen to this quantity? Will it increase or decrease? Let's see. This is decreasing, raised to the power something which is more, which is greater than 0, definitely decreasing. Okay, so there's a concept here. To decrease x, we need to decrease x in that relation that was above. To decrease x, reaction goes, you can see, to decrease the quantity x, if you need to decrease this, what will happen to the reaction? It will go backward. Okay, reaction goes backward. Okay, what happens here is, let's see, in this case, obviously it's quite easy, raised to the power delta ng, and that is 0, that will be 0, and this is quantity equal to 1. It's showing that x is always constant. Okay, here in this case 1 upon P has decreased and raised to the power something which is again negative. Obviously this quantity as a whole will increase. So we can say to increase x, therefore reaction goes forward. Okay, let's go to third category. Okay, third category says effect of inert gases. Effect of inert gas. What happens here? This can be carried out at two different conditions. The first condition says at constant volume, and another condition is at constant pressure. These are the two categories. At constant volume you'll carry out this, or at constant pressure you'll be carrying out this. So it's very easy to say whatever you are doing, be at constant volume or at constant pressure, these two are going to have a different results. Here what happens in the constant volume, it says there's no change in equilibrium. The reaction is not moving forward or backward, it will adjust to equilibrium level only. So it says PT increases, raised divided by delta ng will increase simultaneously. This whole ratio will increase. If this is increasing, this is also increasing. Both of them together are increasing, so there is no change. I hope you are able to understand, and if you're not able to understand, you'll have to see my other videos for this explanation. This is just the review. I can't explain everything here. Okay, suppose if P is directly proportional to N number of moles, okay, then P by N is again a constant. P by N is again a constant. There's no change. Okay, next here what happens is, it's just the simple that you need to learn. Of course you'll have to learn here. By the end, if you're preparing for an exam, you just have to remember it. Okay, reaction moves towards more I'm underlining, reaction moves towards more number of gaseous moles only. The reaction will move towards that side where there is more number of moles only. So our next category is effect of temperature. One is exothermic reaction and another is endothermic reaction. What happens here is exothermic, we'll understand. Okay, in exothermic, okay, the reaction graph, it goes from this level to a lower level. reactants and products. So you can see that the K is inversely proportional to T. Okay, what happens in endo? It's very easy. It will go from here, this level, to a higher level. Okay, so K is directly proportional to T. This is what you need to remember. Okay, so if temperature is increased, therefore reaction will go backward, and if temperature here is increased, therefore reaction will go forward. I hope you're able to understand these. Next, here K equivalent has decreased, and here K equivalent has increased. Okay. Next it says reaction is so we can say there's a big note here that exothermic reactions are favored at low temperature. Exothermic reactions are favored at low temperature. And what is the note here? It is endothermic reactions are favored at high temperature. Okay, since we know that delta H is equals to EAF minus EAB, forward minus backward, full less than 0 here. Okay, in this category. Okay, so a big review for you is temperature only change. I've created two categories, concentration, volume, and pressure at one side. If these are changing, okay, then what will happen? These do not change. These changes, if you're changing this, these changes do not change K equivalent. And if these changes are forward, changes K equivalent. It's gonna change this value. K equivalent value will be changing in this. Okay, watch my another video on this topic, chemical equilibrium, part 2.